Alright, welcome to ePortfolio, problem 1 for project 3. Water at 20 psia and 50 degrees Fahrenheit enters a mixing chamber at a rate of 300 pound mass per minute, where it is mixed steadily with steam entering at 20 psia and 240 degrees Fahrenheit. The mixture leaves the chamber at 20 psia and 130 degrees Fahrenheit, and heat is lost to the surrounding air at 70 degrees Fahrenheit at a rate of 180 BTU per minute. Neglecting the changes in kinetic and potential energies, determine the rate of entropy generation during this process. Alright, so in this problem we have water coming into one and steam coming into the other, and then it's leaving as a mixture of water. Constant pressure of 20 psi inside the mixing chamber. We've got 180 BTU per minute of heat loss. So let's see here. We're going to want to find the rate of entropy generation. So that would be S dot. I want to find S dot gen. Remember, it's S dot since it's a rate. So to find S dot gen, so remember S dot in minus S dot out plus S dot gen is equal to delta S dot of the system. Okay? And we know that this is a steady system, or we're going to make the assumption it's a steady system, so that we know can be 0. Okay? So, rearranging here. Okay, we're going to have S dot gen is going to be equal to S dot out minus S dot in. Okay, so this is what we're looking for. So now we define S dot out and S dot in. Okay, so S dot gen, let's see here, S dot out is going to be equal to Q dot out over TB, and S dot in is going to be equal to this m dot times the sum of our entropies, which in this case is going to be m dot 3 S3. This we're going to label as m dot 3. I'm going to call this m dot 1 and this m dot 2. Okay, for the mass flow rate. So m dot 3 minus m dot 1 S1 minus m dot 2 S2. Okay, S dot gen equals Q out over TB. So this is the main formula that we're going to use to try and find things. Okay, so for right now, really the only thing we know is m dot 1. Okay, everything else we're going to have to try and figure out. So we have three things. We have water, steam, we'll call that 1. Steam is port 2, and then the exit, which we'll call 3. So at the water inlet, we're going to have P1 equals 20 psia, T1 equals 50 degrees F, and our m dot is equal to 300 pound mass per minute. Okay, P2 is equal to 20 psia, T2 equals 240 degrees F, and our exit P3 is equal to 20 again, T3 is equal to 130 degrees F, and our air temp is 70 degrees F, with Q out equaling 180 BTU per minute. Cool? Alright, so At 1, we have P1 and T1, so we can find H1, which is 18.07, S1, which is 0.03609. Okay. H2, we have a pressure and a temperature, so we've got 1162.3. S2 is 1.7406. And S3, H3 is 97.99. And S3 is equal to 0.18174. Okay? So now, if we... Right, sorry, we're not going to go back to the other slide. We're having a technical difficulty. So, alright, so now we know S1, S2, and S3. We know m.1. We know TB, which is our 70 degrees Fahrenheit, which we'll have to convert to Rankine. And we know our Q out. Okay? So, we're looking to try and find m.2 and m.3 in order to solve the problem. So remember though that we can form a relationship between m.1, 2, and 3. m.1 plus m.2, they're coming in, equals the outflow, m.3. Okay. We also know from our energy balance, E in equals E out for a steady system. So m.1 H1 plus m.2 H2 equals m.3 H3 plus Q dot out. Okay. Rearranging, we have Q out equals m1 H1 dot plus m2 H2 minus m1 plus m.2 times H3, subbing in that equation with that equation there. Okay? Now we know Q out, we know m.1, we know H1, we know H2, we know H3. So we can rearrange this and solve for m.2, which we find to be 22.7 pound mass per minute. Okay? Alright. So now we're really pretty close to solving for that initial equation that we had established, because now we've got m.1 and m.2, so by deduction we can find m.3. Which turns out to be 322.7. When you add 300 plus 22.7, you get 322.7. Alright, so let me skip it. Alright, so now we've got just about everything we need to solve for our initial equation of Sgen equals m.3 S3 minus m.1 S1 minus m.2 S2 plus Q out over TB. So we just solved for that. We found that from the tables. That from the tables. We were given that. We solved m.2. We were given Q out. We were given TB. Okay. After converting all these, or TB to 530R, when we plug everything in, we get S.gen equals 8.65 BTU per minute R. Okay? Kind of a long problem, but hopefully that made sense. Thank you.